Okay, so for our first example, it's relatively straightforward. Open circle to closed circle here for our first piece goes from -4 to +1. So we don't include the 1 because the point at the x value of 1 is an open circle, so we can't include that. The point at +2 has a closed circle, so we can include 2. And our second piece continues to infinity in the x values. So this is our domain. And this is a lot like the problems on the front. Okay, this second one has a bit of a curveball. Do you see how these are halfway between? And how these 2 points here are halfway between 2 lines. And each line counts by 2. So this right here is halfway between -6 and -8, that's -7. And this right here is halfway between 0 and 2, that's 1. So our domain is going to go from -7, not including -7 because there's an open circle at the point where x is -7, all the way to 0, and we do include that because the point where x is 0 is a closed circle. And then we union it with from 1 to 6. And there's a parenthesis on 1 because the point where x is 1 has an open circle. And the point where x is 6 is a closed circle, so we put a bracket on that. Now for the range for this one, I've only done the first piece. The second piece has a bit of a curveball. We're just looking at the range of the second piece. It goes all the way down to here. So starting the range here would not be correct, because the range goes from the lowest point to the highest point. It's also important to note that there is no arrow here. That is an end point. So our range is from here to here. And because there's no open circle, the graph does reach +3. And so the real interval notation for the range of this second piece is from 3 to 12 with 2 brackets. And this is, of course, -infinity to -3 with parentheses. So our range is going to go from -infinity to -3, not inclusive, unioned with from 3 to 12, inclusive. And again, that's because this range goes further down than this open circle. It goes all the way down to +3. Alright, let's move on to these. So sometimes the domain and range can overlap, in which case we do not need separate intervals. So when the domain or range overlaps, we don't need separate intervals. So what does that look like? Well, first of all, let's do the domain of this first piece here, in this first problem. The first piece has a domain that goes from -infinity and stops at 1. Right? This is our domain here. But here's the question. Here's the question. Yeah, this is really not showing up very well, this pink, unfortunately. The question is there graph at the x value of 1? Right now we have an open circle because our first piece ends in an open circle. But there is a point on the graph with an x value of 1. So this is not an open circle. 1 is part of our domain, because at x equals 1, at the x value of 1, there is a place where at least one of the pieces, in this case it's the second piece, exists. So 1 is also part of our domain. And then that's all there is to the second piece. It's just that one value. So now we're on to our third piece, which goes from 1 to +infinity. So in other words, every single x value is accounted for, because we have one piece going from -infinity to +1. We have +1 itself in our domain, and then we have another piece going from 1 to infinity. So every single x value from -infinity to +infinity is accounted for. You can see that there's overlap in our domain, and we end up with just a straight up horizontal line covering every single x value. So that's going to go from -infinity to +infinity And if I were asking for set notation, this would be all real numbers. Now for the range. Is the range all real numbers? The answer is no, because although it goes all the way up, the lowest it goes is right here at -7. Right? 1, 2, 3, 4, 5, 6, 7. Yep. So it starts at -7, and the point where y is -7 is an open circle, so our range is going to start at -7 with a parenthesis, because we can't include -7 itself, but we can get as close to it as we want, and it will still be included, so that's why we use the parenthesis instead of a bracket. And it's going to go all the way up because there are 2 arrows here, and every single other value is included in the range, so we get infinity as our upper bound of the range. The reason why we can write it like this as 1 interval instead of 3 is because it's very repetitive to say something like putting something like this, for example. Putting something like that, for example, is extremely repetitive, and it's not what you're going to see. It's just very redundant to do that, and not proper. So, you need to know that this particular piecewise function, because of the overlapping domains, can have a domain written as 1 interval, because they all overlap. Alright, now for the second one, again, you can pause this video and jump ahead if you would like. The second one, the first piece has a domain going from -infinity, stopping at 0. Again, this is 0 because we're looking at x values still. We are looking at x values still. Gosh, if there was a way to make that the paint here show up better. That kind of helps. So it goes from -infinity to 0. And then there is actually a point at the x value of 0 where the graph does exist. And that's on the second piece. So we can fill that circle in because it is part of our domain. And then this second piece goes from 0 all the way to infinity. So this is 1 interval now. And once again, it's all real numbers from -infinity to positive infinity. And our range doesn't go all the way down, but instead it starts here at -1 and it goes all the way up. Our first piece starts at 1. But the second piece kind of overlaps the entirety of the first piece's range. So the range goes from -1 all the way up. And for the last one, we have 3 line segments. So our first piece has a domain from -6 to -2, both inclusive. The second piece has a domain from -2, which we know is included in the other piece, so it is included in our domain. And it stops at 4, which has a closed circle. And the last one has an open circle, but we know that there's already a point at the x value of 4. So 4 is already included in the domain regardless of whether this is an open circle or not. And it goes all the way to 8. Now that's the only point with the x value of 8, and it's an open circle. So that circle actually is open, because this is the only point with an x value of 8, and it's an open circle. So our domain is 1 interval from -6 to +8, where -6 is included, but 8 is not. Now for our range, it's going to start down here, halfway between -6 and -8. That's going to be good old -7, and it is included. And it's going to go all the way up, because, keep in mind here, right now the range is the range of the first piece. Then the second piece here overlaps, like the middle piece here overlaps, and then the upper piece overlaps, and so we go all the way up halfway between 8 and 10, because that's where that point is. That's the highest point of the function, the maximum if you will. It's at 9. So it goes from -7 to +9. And there you have it. That is piecewise domain and range.